Hello all and welcome back. So in this video, let us continue our discussion on trees and now let us try to understand it a lot better using some examples. So let's get started. Now these are the two examples which we talked about in the last video where the family tree and organization structure is something which is a lot intuitive to understand, right? We saw an example of family tree as well. Let me draw that again once. So the tree overall is going to be something like this. So we will start with a node, okay? And it can then have any number of children. Now, many of you might get confused here because normally directly binary tree is taught. Okay, so that is not the case. Binary tree actually comes after this generic tree, right? So in a tree, normally a node can have any number of children, right? So this is, let's say, a structure in which we can represent this tree. Now, I explained you how this is analogous to tree, just a tree upside down. Few things to notice here is that we cannot have a cycle here. So we cannot actually have this join here. That would be a problem. Okay, this should not be there. Should not be a cycle, right? So rather not should not be a edge as it would start a cycle. So this is not the case. Again, very important to understand. One more way to look at trees. Okay, and let me first explain a little bit more. So this is an example, let's say, of a organization chart. So this can be the CEO. Then maybe we can have VP here. Okay, some director here. And under this director, okay, maybe some vice director or something is there. So maybe SVP is there. Okay. So I think SVP, senior VP, no worries. Maybe we have some, let's say, developer under the director. Okay. So this is the kind of an organization chart. Now again, it's a hierarchical data structure as we can see. One more way to look at trees, and a very important way rather, is that we can imagine tree something like this as well. So each tree, each and every tree which we have, okay, that can actually be said to consist of multiple sub trees, right? So let's say this is one node. Then we have this particular node and say this particular node as well, right? Now, what I can say effectively, let me just copy this so as to make it of same size. One. So let us just have this particular node. One second. What effectively I'm saying is that we can have these nodes which are like this, and each and every node can then internally have a subtree under it, right? So what I can imagine is that if this tree has some child, right? So just like in my linked list, I was able to break my linked list by taking a single element because after that everything used to be a linked list, right? So we saw that thing that how, let's say if this is my linked list, I can actually say that, hey, after breaking this first point, the rest is also my linked list, right? The rest is also my linked list. Rest also a linked list. In a very similar manner, we can actually say that this particular subtree is another tree, right? So this is another tree. And you have to understand one thing always in problems as well as normally, it's a very good way to just imagine a tree something like this. So this is a tree. Under my tree, we have two or multiple sub trees, which I can just draw like this maybe. Okay. So any problem is there. Okay. We can fabulously use recursion there as well. Okay. So we are going to talk more about it, but I want to make sure that you understand that each and every of these sub trees, they can be individually treated as a tree because this is my node or the root. Okay. The root node. And then we have the left and right or maybe multiple children as well. So let me draw multiple children here. Okay. So we can have a multiple children as well here. Right, everyone? So let us now move forward and see some examples where it can be used. So we saw some real life examples. Let us see some practical example as well. In practical examples, right in front of you, like you will be watching this overall on some laptop or some phone, right? We have the example of file structure. So in my file structure, what happened is that I have a overall folder, let's say home folder. Now under that you can add downloads, document, something like this, right? So you can have the home folder. Under home, we can have some documents. We can have downloads. You can even make your own folders, right? And then under these folders, maybe in downloads, you have internet downloads from the internet, some other downloads. In documents, you can maybe have some PDF, some images. So this again is the structure which can be very nicely overall implemented and visualized via a tree data structure, right? In a very similar way, a very famous algorithm of machine learning, decision trees, is where trees are used. We take the decision based on some condition and draw the overall tree based on our data. Okay. So these are some practical examples. Now let us see some industry based example as well, everyone. So industry examples. Now I'm telling you all this because if tomorrow in an interview or normally as well, you have to explain someone or actually remember that where trees are used, you should have these examples ready, right? In many interviews, I have been asked for a real life, practical, or let's say industry use cases for the data structures. Okay. Now here we have the indexing in databases. So moving forward, we are going to see that how binary search tree is a lot helpful in searching for any particular item, searching and retrieving. So in a similar way, there are many variations of my simple tree, the generic tree, which we are studying. So this you can just imagine as a generic tree, due to which we can actually do indexing in our database a lot nicely. Okay. Then the next is network routing. So in networking, it is used a lot so that we can do efficient network routing of our request. And then there can be HTML document, HTML document object module, so HTML DOM. In that, how is the structure? We have the HTML tag overall first. So we have this HTML tag. Then under this tag, we have different tags like index, heading, title, all these are there. So there also, of course, a tree can be used very nicely, right, everyone? So I hope you understood that these are the industry use cases of my tree, and along with that, practical and how you can just normally see tree all around you. So these are the ways. Now, just make sure that you imagine trees something like this, the way I've told you, because each and every subtree, each and every node, root and node can actually be in a way thought of as a subtree. A better example of this is like, let's say your great grandfather will have a overall family tree, but this family tree you can just take this part out. Maybe this is the your grandfather family tree. Okay, so it in a way is also a separate family tree, right? So please make sure that you understand this as well. Just like we were able to break our linked list, we can also say that our tree has multiple subtrees. Okay, and just like we have the head node, okay, we have the head node, we have the root node here. This is known as root, something which we have discussed, but yeah, like we have head in linked list, we have the root node in this. Okay. So great, everyone. I hope all these examples are clear. Now in the next videos, let us understand some terminologies which are very helpful in defining or talking about our trees.